In this video, I'm going to talk about something called Chebyshev's rule, and what it says that regardless of the shape of the distribution, meaning whether the distribution is bell-shaped or not, then at least 1 minus 1 divided by k squared percentage of the observations will lie between mu minus k times the standard deviation and mu plus k times the standard deviation. So here I have a set of population data that's GDP per capita of the 214 countries around the world. So the first data is located in cell F13, and then the last data is located in cell F220. The last data right here, this is in cell F226. The average is 21,428.36 cents. And so now let's go back to what is Chebyshev's rule. So what Chebyshev's rule says is this: regardless of the distribution, whether the distribution is bell-shaped or not, then at least 1 minus 1 over k squared percentage of the observations will lie in the interval mu minus k sigma, mu plus k sigma. So in our case, for this population data of GDP per capita, the population mean is $21,428.36. The population standard deviation is 31,303.63 cents. And so k here has to be a number greater than 1. So pick any number we want greater than 1. So let k be 2. So pick any number greater than 1. And then if k is 2, then 1 minus 1 over k squared will be 1 over 1 minus 2 squared, or 0.75. So 1 minus 1 over 2 squared will be 0.75 times 100%, then we get 70%. And so what Chebyshev's rule says that at least 75% will be of the GDP per capita data will lie inside this interval. The interval of mu minus k sigma, and then mu plus k sigma. Again, mu here is the population mean, so it's $21,428.36. Here we're letting k be 2. Once again, k can be any number we want greater than 1. And so 2 times the population standard deviation of $31,303.63. And then instead of minus, we'll have a plus here. And then simplify this part, then we have negative $41,178.90. Simplify this part, then we have $84,035.62. Now we know that for the population GDP per capita data, it cannot be less than 0. And so in this case, the smallest value that we're going to have is 0. And so what Chebyshev's rule says in this case is that at least 75% of the observations will lie between inside this interval. And then in a few minutes, we're going to go back to the data and check and see if this is true or not. And now instead of k being 2, let k be 3. If k is 3, then we get 1 minus 1 dividing by 3 squared, which is 1/9. 1 minus 1/9 is 0.8889. Multiplied by 100%, then we get 88.89%. And so once again, Chebyshev's rule says that at least 88.89% of the data values, in this case is the GDP per capita, at least 88.89% of the data values will lie inside this interval. And so this interval, this is the population mean once again, and then this time k is 3. So we have 3 times the standard deviation, and then here we have the mean plus 3 times the standard deviation. And then simplify this part, we get negative $72,482.53. Simplify this part, we have $115,339.25. Once again, for this set of data, GDP per capita, the smallest value has to be 0. It cannot be below 0. And so what Chebyshev's rule says once again, at least 88.89% of the observations will lie inside this interval. And then we'll go back to the data set and then I'll go back to Google Sheets, and then we'll check and see if this is true or not. And then the last one, when k is 4, then we get 1 minus 1 dividing by 4 squared, and then work all this out, we get 93.75%. And so once again, Chebyshev's rule says that at least 93.75% of the data, GDP per capita data, will lie inside this interval. So this is mu minus 4, which is k, and then times the standard deviation, and then mu plus 4 times the standard deviation. This part will be negative 103,786.16 This part will be $146,642.88. And again, the smallest value for this set of data is 0. And so Chebyshev's rule says that at least 93.75% of the observations of the data will lie inside this interval. Now let's go back to Google Sheets and check and see if all of this is true or not. So here we have the set of data right here. The first one is in cell F13. The last one is in cell F26. And earlier we calculated that the population mean is 21,428.36 cents. And then the standard deviation is $31,303.63. And then once again, to calculate the standard deviation using Google Sheets, we use the function STDEVP. And then specify the range. The range in this case is F13 to F26. And then it will give us the standard deviation. When k is 2, and then 1 minus 1 over k squared is 0.75. And then the mean minus k times the standard deviation. We calculated this earlier. It's negative 41,178.91 cents. The mean plus k times the standard deviation is $84,035.63. And now let's get Google Sheets to count how many values of the GDP per capita data are between these two numbers. And then in an earlier video, I have shown how to count the number of values between these two values. So to get Google Sheets to count, we would use the function COUNTIFS, and then first we have to specify the range, and then next we have to give it the first condition. So we want everything greater than this value, greater than negative 41178.91, and then we want everything less than this value. So you have to specify the range again, and then you want everything less than 84,035.63. And it will tell us that there are 200 out of the 214 values, GDP per capita, 203 values are between these two values. And likewise, when k is 3, then 1 minus 1 over k squared is 0.8889. Mean minus k times standard deviation is negative 72,482.55 cents. Mean plus k times standard deviation is 115,339.26 cents. And then the number of values between these two numbers is the number of GDP per capita values is 210. And then when k is 4, we have 1 minus 1 over k squared is 0.9375. Mean minus k times standard deviation is this number, and then mean plus k times standard deviation is this number. And now let's get Google Sheets to count the number of values, GDP per capita data values, that are between these two numbers. It'll be 212 out of 214. And so for the first one, when k is 2, there are 203 values are between these two numbers. And then so we do 203 out of 214, or 203 dividing by 214, then we get 94.5%. So this is the same as 94.86%. And then 210 dividing by 214, then we get 98.13%. And then right here we get 99.07%. So 94.86% are between these two values, 98.13% are between these two values, and then 99.07% are between these two values. When k is 2, Chebyshev's rule says that at least 75% of the data values will be between these two numbers, but the actual percentage is 94.86%. When k is 3, Chebyshev's rule says that at least 88.89% will be between these two values. Between these two values, but the actual percentage is 98%. When k is 4, Chebyshev's rule says that at least 93.75% will be between these two numbers, but the actual value, the actual percentage is 99.707%. And so that's how Chebyshev's rule work. And so this is the end of it.